Good afternoon. I hope you all had a nice lunch. We're going to go ahead and get started now. If you wouldn't mind finding your seats. I'm sure some other people will trickle in. They're all in the courtyard still. Up next, we have Michael Wuehler. He's founder of INFURA. INFURA is the Ethereum and IPFS infrastructure spoke at Consensus. Previous to Consensus, Michael was Senior VP at Bank of America and in the CTO organization, where among many other roles, he ran middleware and messaging globally for the global markets line of business, and most recently served as COO for the engineering teams working on software-defined infrastructure. Michael has a master's degree in information systems management and an MBA from the University of Chicago Booth School of Business. Please join me in welcoming Michael.
It's okay. I'm very excited to be here today. I know Tyler left the room. I wanted to thank him for inviting me to this excellent conference. I feel like it's been incredibly run as well. I'm happy to be here to talk about INFURA. Just to the agenda, I'm going to talk through an introduction. I'm going to go through a little bit of history. We'll talk about a chasm and some maths. And I'll talk about reducing friction with INFURA, and finally, the state of INFURA today. So I was introduced a little bit, but this is a little bit of more of my background. Of note, I was an internet engineer from 1995 for the first 10 years. And it's really interesting the parallels that we're seeing in this kind of wave of technology that kind of happened in the late 90s, leading up to the dot-com bubble burst. Some may say we're heading for a bubble in this industry. Well, it could be true. But hopefully I'll learn from some of the lessons from that time and be able to kind of survive a little more easily this time. And also my experience with cryptocurrency or the blockchain space. I came involved with Bitcoin in 2011. In 2014, I first learned of Ethereum. I read the white paper from that Vitalik wrote and presented in Miami. And I started a meetup in New York City just so I could get engaged with people. That meetup today has over 2,200 members, second largest meetup in the world after London. So since we're at a business school, and this is a great institution of learning, I wanted to give my obligatory B-School slide. So this is our diffusion of technology. I think you've all seen this, right? This is your innovators, early adopters, the early majority, late majority, and your laggers. So this kind of hype cycle, or this cycle, occurs over and over whenever a new technology is introduced. For example, let's look at what happened in the 1980s or the early 1990s with the PCs. So if you were in the late 1980s or the early 1990s and you were finding yourself at that location on the early adopter cycle, here's the sort of things that you would be seeing to happen. You've got your blue screen of death, you've got your sad Mac. All these things kind of are in distant memory now. PCs kind of are pretty stable. You've got iPads, you've got other things, personal computing devices. You don't really run into this kind of stuff anymore. Back in those days, my mom would always call me and say, my machine is blue, I don't know what to do. How about the World Wide Web, 1990s? If you were there at that location in the hype cycle, what was going on? You would have AOL, a 19-hour outage in 1996. Can you imagine if the internet had a 19-hour outage these days? eBay had a 24-hour outage, $3 to $5 million of losses in 24 hours. It's kind of in small print, but Amazon in their latest Prime Day sold over $500 million in one day, so it's kind of interesting to note. So what about blockchain, mid-2010s? If you're in that location in this cycle, what's going on? You've got things like Mt. Gox, you've got an exchange being hacked, 450 million USD being lost, 1 billion USD at today's prices. Or in the Ethereum world, we have the DAO that happened last summer. 3.5 million Ether were lost and about $50 million at the time. 175 million at today's prices. So what is the issue with that particular location in the hype cycle? Jeffrey Moore, in a book called Crossing the Chasm, introduced this term called this chasm that occurs kind of right at that location. It's about the 16% mark. And so you've got people the early adopters and these innovators that know how to do this, but these late early adopters and early majority kind of get stuck at that chasm. They're trying to get over that, but things are too difficult. They don't know how to deal with it. So that chasm is also called the trough of disillusionment in the technology hype cycle. You might have seen that other graph. I feel like Bitcoin got through that. Ethereum is kind of maybe down low in that hype cycle, but working its way out. So what causes this chasm? I was thinking about it, and I realized that I could come up with some math that would help us understand that. So let's dig into some math. If you went to the B school, you did the GMAT, so dust off that. You can, let's dig into some equations here to figure out what's really causing that. The equation I came up with is H equals R minus E, and the long form of that would be happiness equals reality minus expectations. So Vlad Zamfir, who's one of the core developers of Ethereum, also could be called one of the chief sanity officer for Ethereum, made this tweet last month. Ethereum isn't safe or scalable. It's immature experimental tech. Don't rely on it for mission critical apps unless absolutely necessary. Now, some would say, why would one of the core developers of Ethereum come out publicly and say something like this? And in fact, if you remember William's slide yesterday where some of the disbelievers in Ethereum view Ethereum as a completely broken car, they use this as evidence to say that, look, Ethereum is doomed, like their chief, one of their chief researchers is saying this publicly. But I think what Vlad was really trying to do is he's trying to kind of curb that whole reality versus expectations that's going on right now with this blockchain technology. So what's happening? The change in expectations in blockchain is growing faster than the change in reality. The reality is coming along, there's lots of research, but we're starting to place a lot of expectation in what this stuff can do. So when that happens, you've got a situation where reality is less than expectations, leading to negative happiness. So, got people falling off the cliff. So how do you cross the chasm? What's a two-step program for that? First, identify friction points or barriers to entry, and then build tools to reduce the friction, or eliminate it altogether if you can. That would be ideal. So what are some of the friction points? These have been discussed in the last few days, today and yesterday. There's lots of groups that are working on solving these friction points, scaling, privacy, identity, key management, and more. INFURA, which I'll talk about in a minute, is also trying to address one of these friction points. So let's look at the current situation of two people communicating on the internet. There's Alice. She's used to communicating with Bob, her friend, by sending a message through a centralized source such as Microsoft or Google or Facebook or Apple. And they're very happy because they're communicating. What happens when they move to a decentralized situation or a decentralized network? Now those intermediaries are no longer needed and peer-to-peer connections are enabled. So you've got Alice, who's got her smartphone, but she doesn't know what Ethereum is. And Bob on the other end, who does know Ethereum, but wondering, like, why won't Alice send me any more messages? It's because Alice doesn't know how to participate on the peer-to-peer network yet. So enter INFURA to try to solve that situation. So INFURA's mission is to provide the world with secure, stable, fault-tolerant, and scalable Ethereum and IPFS nodes. Some of the features, and I'll run through these. We provide public HTTPS-enabled endpoints for the Ethereum mainnet and the testnet networks. That's plural now. There's multiple testnet networks. It's a portable interface. It's fully compliant with standard JSON RPC API. So there's lots of different libraries and different languages that are written in JavaScript or Java or Python. You can use those libraries to interface with our gateway endpoint to communicate with the Ethereum blockchain. We have a worldwide peering footprint. We strive to have the best peering in the Ethereum network. I'll talk about that on the next slide, a couple of slides from now. We also have a multi-client Ethereum backend. We run Geth and Parity simultaneously. If one or the other has problems, we can route traffic to the other. This was very valuable last fall when the Geth client was attacked. We were able to quickly route traffic over to Parity and continue servicing our clients without any issues. We also give public HTTPS endpoints for IPFS. That's a gateway for decentralized storage, and we're developing additional pinning capabilities to make that more reliable for our users. We've developed a service layer, which we call Ferryman, which we've enabled some caching, some throttling, denial of service prevention and logging, et cetera, where we can do analytics. And finally, all of this can be deployed as a private or consortia installation. We expect to build out an offering based on the EE reference implementation standard as that gets defined. We'll look at the INFURA architecture. We call it a boomerang. So in the top left, you've got your decentralized apps, your users. They connect through just a single endpoint gateway, which routes traffic to our Ferryman service tier. At that layer, we're able to do caching, logging. So if someone just wants to ask, what's the latest block number? We don't have to go to the blockchain and ask the blockchain what the block number is. That only changes every 15 seconds. We can cache things. So we've seen things such as 8x improvement in servicing requests as they come in by not having to go to the blockchain every time anyone asks to kind of read data. Ferryman then will route the request to the appropriate network. There's only one implementation of a testnet in the picture, but right now we have several different testnets: Kovan, Ropsten, Rinkeby, INFURANet, and the mainnet, of course. And similarly, Ferryman will route traffic and requests to IPFS if it's requested that way. So I talked before about our global footprint. We partner with Microsoft in York, who's been very helpful. Kale Teeter, who also works at Microsoft, one of the unsung heroes, I think, in this space, helped us develop a peering methodology whereby we have deployed peer nodes in all 32 Azure data centers. When we start our main core Ethereum network, we instantly boot and peer with all those 32 so that we're immediately only a few hops away from almost any node on the rest of the 10,000 nodes in the Ethereum network. So what is this? This is INFURA as a zero client. So what is a zero client? A zero client, for example, runs in the browser in JavaScript, maybe something like MetaMask if you're familiar with that. And it uses a gateway service on the back end to communicate with the blockchain. And what does this do for you? What's the benefits of a zero client? It gives you accessibility. You've got no more hardware minimum requirements. You can use a phone now to communicate with the Ethereum network. There's convenience. You don't have to wait to sync the blockchain. If you've ever downloaded one of the Ethereum clients, you'll know that it takes several hours possibly to sync up to the latest block on the network. There's 3.5 million blocks on the Ethereum network at this stage, and we're only less than 2 years in. Can you imagine in 5 or 6 years, it'll be nearly impossible for any normal user with their laptop or personal computer to have a full node. And then, of course, redundancy. As I said before, we have load balancing so that if one particular node that you're connected to starts to have troubles, we can throw it out of service or route traffic differently. Finally, security. If built appropriately, you can sign transactions offline and then relay them as raw transactions when your network connection is available again. So in a picture, this is what it looks like. You've got your regular user using the static front-end web page like they're used to today, and that application uses Ethereum as its gateway to communicate with a broader Ethereum network. So if we go back to Alice and Bob, what we'll see is now Alice, with her phone, is using INFURA as a gateway, and now she can communicate again with Bob through this decentralized peer-to-peer network. So now I want to talk about a little bit of the applications today. Some case studies of how INFURA has been used. A lot of talk about Gnosis in the last couple days. Behind the scenes of all this, INFURA was the back end for the Gnosis token launch, or the token auction. So if you can imagine a spike in traffic like that, you need to ensure as you're building applications that your apps are capable of dealing with spikes. And if INFURA behind the scenes was capable and able to do that so that without a hitch, Gnosis was able to complete their auction in under 10 minutes and meet their goals. Looking at our growth and stability, so that's a 3-month chart. I know it might be a little hard to read. On the far left axis, the number there is 20 million. So 3 months ago, we were getting 20 million requests a day. On the far right, the value at the top is 175 million. So we're seeing enormous growth. That's more a statement of kind of the overall growth of the Ethereum network as a whole. I think there's lots of metrics that show hockey sticking going on and lots of different metrics on the Ethereum network. And along the same lines, we've been able to do that with relatively high uptime, near 99, 100%. So in short, what we're trying to do in INFURA is aim to eliminate the friction. We put ourselves in that chasm, and hopefully users developers and decentralized app users will be able to cross that, and we'll get this technology diffused much more efficiently. Thank you. Sure. Questions? Yeah.
So you mentioned Gnosis was a customer or user of this service. They just completed crowd sale. I believe, do you know what transaction volume actually was that they pushed through per second or any measurement there?
There were 574 unique transactions in that 10-minute period. So it's not a huge transaction per second. Those are actually purchases. When I talk about the 175 million, I'm not talking about transactions. I'm talking about total requests to the RPC endpoint. There's lots of reads that happen, lots of market data that people want to do in their dApps versus just sending transactions. There's only about 80,000 transactions a day on the entire Ethereum network at this point. Yeah. Alex.
Can you tell us what percentage of those are coming from MetaMask and 10%?
Yeah, so a large percentage or a large component of our traffic is coming through the MetaMask browser. I think if you've used Ethereum, you probably are familiar with MetaMask. So everything that MetaMask does and everything that is enabled by MetaMask is because of the fact that they're able to leverage a zero-client gateway on the back end. So out of that 175 million, I'd say like over 90% at this stage is coming through MetaMask. Yeah.
How do I get started if I have a dApp and I want to roll it out?
INFURA.io and sign up for free and use our service for free. You'll get an email that tells you how to do it, or email me and I'll walk you through it. All right, thank you.